Okay. Now start. Okay.
Okay, sir.
Just 1 minute.
Still, sir. Still, sir. Say to you, sir. Say to me, the host. Permit me again, sir. Hello, sir.
Now you waiting. Now just
Okay, okay.
is this any problem?
No, sir. No.
Why not sound?
Oh, sir. Permit me the recording again, sir. It rejects me, sir, to record.
Okay, already recorded. No problem. Okay, now I am mute. Okay, and you start.
Okay, okay. Give me the permissions. And we'll talk about the And here we will start the first generation of Intel microprocessor. And the first generation, of Intel microprocessor was invented in 1971 by by Intel technology. It is a BMOS technology, non-compatible with TTL, and it has 4 bits in a 4-bit processors, and also there are more which has 8 or 16-bit processors, and also 40 pins. So why it is halt this first generation? Because of a limitation of bins, and also this generation. And the second generation was invented in the year 1973 NMOS technology. According to the first generation, it is a much faster speed than and higher density. It is also compatible with TTL. So this has 6 and 8-bit processors, and also for the pins. So why they use, why they choose to invent this second generation? Because of it has ability to address large memory space and I/O pods. So it has also a greater number of levels of subroutine nesting, but interrupt handling capability. So Marka, and the second generation was Intel 8085, and also it has a 8-bit processor and 40 pins. Third generation. The third generation was invented during 1978. HMOS technology, faster speed than the second generation, higher packaging density than the second and first generation, and it is a 16-bit processors, and also 40 pins. Why they use them? Because of it is easier to program, and also it has more powerful interrupt handling capability. So it is a flexible. It has a flexible I/O burst addressing, and also it is called third generation was Intel 8086 16-bit processor. That is what we want to talk about today. The first generation was invented during 1980s. It has a low power version of HMOS technology. It is 32-bit processors. So it's a burst increased the number of addressing modes. So it was Intel 80386. The other ones up to now, the fifth up to now, we are using the Pentium. There we can divide Pentium 1, 2, 3. So the fifth, and up to now we are using the 5th generation of an Intel microprocessor Pentium. So here we have how do it work, or what is inside that microprocessor 8086. So here it has a functional block. It is a functional block. So how do it works? And the main function is that the Intel 8086 microprocessor does or do is 3 of them, which is data bus, address bus, and control bus. So the main function is this, maybe or either be data bus, address bus, or control bus. So address bus, it is a bidirectional, means it has input and output. Address bus, it is output, and also control bus, it is input and output. It is a bidirectional unit. So it contains 6 main parts, which is a ALU, flag register, timing and control unit, register array or internal unit, instruction decode unit, BCB/IB. So how do they work, or how it works is this. So this part ALU means arithmetic logic unit. It performs only an arithmetic, like, and as we know that arithmetic is like the plus, so addition, so subtraction, minus, or multiplication. And also logic operations. As we know that logic operations was AND gate, OR gate, and also NAND gate, XOR gate, XOR gate, NOT gate. So the second one was the second one is flag register. So Marka, in this part flag register, and it is stored in a various conditions of results as status bit is they're called flag is in flag register. So in this part is internal storage of data, means we store data, storage of data. Okay, the PC slash IB means instruction boundary. So and this bird generates address of the instruction to the fetch. Fetch means carry from the memory and send through the pass address to the memory. And the instruction decoding unit. So as you know, we have lengths of decode or encode. So decode is instructions or information is send this information to the team in a time and control unit. So what does the time and control unit do? So in this bird generates only control signal for internal and external operations of the microprocessor. So here we have the overview about an Intel 806 microprocessor. So it's 16-bit processor it has released by the Intel in the year 1978. So it originally from HMOS manufacturer using HMOS 3 technique. So and approximately it is contained 29,000 transistors and 40 pins. It is a DIB and also it has a VCC, which is a 5-volt supply. So these 806 that internal clock, but it has symmetric external clock. So in these 806 Intel microprocessor has even or lower bank or higher bank address. So address lines starts from A0 up to A15. It's used to select an even or lower bank and control signal, which is called BHE node, which is bus high enable, which is used to access or bank. Okay, the last one is, and this microprocessor operates in two modes, which is a minimum mode and maximum mode, decided by the signal at MN and the MX pins. So here we see pins and signals of an Intel 806 microprocessor. So we'll talk about first of all the common pins. And AD node up to AD15, it is a bidirectional and it is also called address data bus, thereby bidirectional unit. Okay, AD19 up to AD16 up to AD19, and so these address data bus are classified into two, which is a lower address data bus and also higher address data bus. The lower address data bus, they are AD0 up to AD15, but the higher order address bus, and there are AD16 up to AD19, and also they are multiplexed with starter signal, which is a S3, S4, S5, and also S6. So in a BHE means a pass high enable. In this being is multiplexed. No, yes, it's multiplexed by starter signal S7. So this is the output being. Why we use this? We use only to enable data onto the most significant algorithm. Means we use only for example D0 up to D8 or D8 up to D15. Means half of the data bus, and also it is an 8-bit device and it is active low. So here we will see this being MN/MX per. So this being signal indicators that shows us what mode the processor is to operate in. Means the microprocessor can only work only one bit, which is it can be minimum or can be maximum. So these being indicators to you what mode your processor is operating, if it is minimum or if it is maximum. Maximum and the minimum being has also its own pins, and also maximum has also its own pins. Okay, right. This is a read and RD. It is a read. It is an output signal. And why we use this? It is it is active low. Why we use it is read only for read only for operations. Read for operations only. Okay, test. So this bean, it is an input bean, and it is tested. It is tested by the wait instruction. Means your microprocessor will enter a state wait, a wait state after the execution, means after the generation of the wait instruction. And when it generates an instruction, so it will resume, means it will continue the execution only when the test is made by low by active hardware. Sorry for internet. Sorry for internet interrupt. Okay, we are in and this is state is ready being. So in this ready being, it is an input signal, it is an active high. So what does it do? And they only do and to slow down that transfer that's already and has already been completed. Means to slow down. Oh my god, معلش مشكلة والله معلش والله shit. Hello sir. Hello sir. Niyo macallinkii oo iska baxaniyo ma khadkan oo iga tegin baalkan jiko inuu
boosu codkaaga fasiix waayo waa la noqdaa
niman yo maxaa qaldan? Hello sir.
Yes, sir.
Sir, can you hear me?
Yes, I can hear you.
Aan nagu ciyaarin. Fiiri 11 ahayd balanka maxay tahay 4 saac maalinka xiisad iska bilaaban.
Wait. Don't chapter.
Wax jira ma aan waxaan balan malaan. Mun dhegeysanaya. Waana sugar oo naga yeelana. Ani class gormu bilaab. Hello.
reede idrisna ma macalinka cudur ku dartay ama isla noo dhameey
waxaas dhan maxaa ka daran taqaanaa niyo balanku wuxuu ahaa 11 daqiiqo hadda xiisada almost bilaabatay waxbaana dhaafay baadhowtana videogiisa saaxib waana caajisnay dib loo daawan ma karo goormay bilaabatay
wallaahi been saaxiib 10kii iyo xogaa bilaabata 20 minute shan haddana saacadda oo dhacday
kala galaal raaco maalin kastoo shan lagu ciyaari hadda maxaad mataqaanaa maanta oo kale ma aragtay maanta oo kale inuu bilaabo maxaa la yidhahdaa 11 inuu bilaabo xariibkii kale 12 ku ahaa soom
صح
maadada kale 12 ahayd marka almost dhini waxa kale galaal raaco hadda anagu waa ku xisaabtan 11 ku bilaabanaysa markaan magaaladeeda galo wixii aan soo sameeyay markaan ama xiisaha uma taqaana almost socoto
ما قاعد حد اللي تعبيرنا
Hello. Hello. Yes, sir.
Yes, sir. Internet is connected, sir. Happening, sir. I talked to you to request me, sir, the remote control again, but you didn't say something there.
Okay. So just now I will continue. Okay.
Sir,
Okay, sir.
Your class time 11:40, right?
sir, may I ask you a
Next one.
question?
Sorry.
May I ask you a question?
Okay. No
I have a
problem.
question. Sir, the class must be start at 11 a.m. as you told us before, but you started before 11.
Sorry, just one. Hello. Idris. Idris. Hello.
Yes, sir.
সাইফুল।
জি স্যার।
Yes, sir.
কি সমস্যা ছিল? ইদ্রিস কি বললো জানো?
স্যার ইংলিশের কথা আমি শুনতে পাইনি। তোর সাউন্ড অফ হয়ে যাইতেছে বারবার।
আচ্ছা, ও কি ক্লাসে এগুলো তো আমরা সব আগে দেখাইছিলাম, তিন ডায়াগ্রাম, তাই না? আমির,
Yes, sir.
today your next class maybe 12 p.m., right?
Yes, sir.
Who is teacher?
Mr. Bizur Rahman.
Mustaqil. Okay. So today I will continue 12 p.m.
12 p.m.
Yes, continue. Yeah.
But sir, 12 p.m. We have a class for Mr. Bizur Rahman, sir.
I know, but now I will start in this time to 12 p.m.
Okay, no matter, sir.
Okay, clear?
Okay, clear. Have you started before?
Sorry?
Have you started before? I mean, like,
I will
you start
continue.
at 10 a.m.?
Any days our class schedule 11:20. Okay. Today I'm
Every
just
day.
busy. Yes. Every Tuesday our class time 11:22. Sorry, 10:22, 11:40. Okay. These are
10:22?
scheduled class. No problem. Okay.
Okay.
Every Tuesday our class schedule 10:22, 11:40, and Wednesday our class schedule 10:22, 1:40 p.m. Okay. So our regular
1:40.
1:40. This is the Wednesday. Wednesday our theory and lab class.
You mean tomorrow?
Tomorrow our theory and lab class. But today our only theory class. Okay.
Tomorrow, when will you start? From 10 a.m. 10 to 1 a.m.
Yes, 10:22, 1:40 AM. 2 classes, 1 theory and 1 lab class.
But sir,
In our scheduled class, your routine
Okay.
class, okay? Check your routine. Clear?
okay, sir. Okay, sir.
This your routine schedule class, okay? So every day our class starts schedule time. Okay, no problem. Okay. Okay, now we start. Previous day already complete our pin diagram.
Yes, being on signal.
All whole are completed, right?
Yes, sir.
So now this the our maximum mode pin diagram, request and grant, log, and status 3 and queue status. These queue status are forwards, and these the request and grant, and this sorry, is the status. This status is the 3 status. Okay. 3 status, all are 0, then interrupt acknowledgement is active. You know that our previously 24 number pin is interrupt acknowledgement pin. Minimum mode. This is the minimum mode. Interrupt acknowledgement.
Yes,
Okay.
sir.
And 17 and 18, this is the interrupt request pin. Okay. These 2 are interrupt request pin, and this is the interrupt acknowledgement pin. But our maximum mode, these pin all are omit, right?
Yes, sir.
These all are omit in our maximum mode. So these are interrupt request pin 2. So maximum mode must be needed at interrupt acknowledgement. So our interrupt acknowledgement pin in active, our these 3 status are combined one. If 3 status all are 0, then interrupt acknowledgement pin active. Okay, this is the maximum mode one, and this the this 2 0 and this the 1. Then the read IO port, and this the write IO port. Read memory, write memory. Previous our minimum mode all are sorry, this minimum mode all are this the in memory and IO bar, write memory, write. Okay, these 2 are height in our maximum mode. So this no need these 2 pin. Our status pin work this. Okay, our status pin, if both S20,
It is 1.
S10 and S01, this is the read IO port, and this is the write IO port. This is the read memory, write memory. All are working 3 status. These 3 status are 8 work. Clear? Okay, so all are complete in our previous class. Just I will discuss some topics. Okay. So already finish our pin diagram, and this is the architecture. Architecture not finished, right? Idris or Amit? Anybody
Yes, sir.
response? Quick response. Architecture not finished, right?
Yes, sir. In the previous class.
Previous class architecture finished. Yes, architecture.
Yes, sir.
Just diagram finished, not the discussion. Discussion all finished. Yes,
Awesome.
discussion also finished. This is the general register AX, BX,
Yes,
BX.
segment register.
The segment register is 4. 4 is
Yes,
the
yes.
segment register. Okay.
Yes, sir. Yes.
The code segment, data segment, stack segment, extra segment. This is the IP.
IB instruction
IP
pointer.
Instruction pointer. This what the
Address
our
generation is. Address. bus.
address
Yes.
previously generate the address location. Okay.
Yep. Yes, sir.
This is the internal communication register. This all are complete. Okay.
Yes, sir.
Okay,
Sir, what these are section and what is the work of this section, internal communication register?
Internal communication register. Internal communication register means our all internal. This is the one kind of register. This register is internal communication.
Okay.
Okay. Internally what? Just reserve register. Okay. It's called reserve register. Okay. And this is the temporary register. One kind of temporary register also. This is the temporary work register. At first, temporary data received, then work finished, then temporary register is vanished. Temporary work is vanished. Data erase. Okay, new data is coming. This is the transfer to ALU. This is the continuous the work, then work finished. This is the transfer, then temporary register is empty. Okay, blank.
Yes,
Okay?
sir.
This is the internal control system. You know that control whole system is controlling. This is the internal control system, and this is the bus control logic. This is the bus control system. Okay, this is the two are control systems. Okay, this part is
See these bins, sir.
sorry.
These bins are 8086 bus. What does the this bin do?
This is the Q instruction.
No, sir. The bus logic, sir. The bus
Bus logic.
control logic. Yes, this bin.
Bus control. Yes,
It is
yes.
bi-directional.
Yes, bus control logic.
Okay.
This is the data. This 8086 bus, and this is the address bus. This is the data bus. All our bus control is the bus control logic. Okay. These the two part. This dot means this is the two section. This section name is execution unit, and this is the bus interface unit. Okay, this is the bus interface unit, and this is the execution unit. Okay, clear? Half section. This section is execution unit, and this is the bus interface. Clear? All are discussion this. Okay. So this was your one question. This question is the architecture of 8086 microprocessor and discuss the architecture. So whole discussion or discussion only bus interface unit part discussion. Draw the architecture. So whole are draw. Then just discussion. Your question suppose discussion only execution part discussion. So your discussion only execution part. And suppose discussion bus interface unit, so only with discussion bus interface part. Okay, depend on your question. Clear? Anybody just response? Hello.
Yes, sir.
Why not response? Bangali keu nai tumra?
Yes, sir.
আসলে তো রেসপন্স করো না কেন? অন করে রাখো, সমস্যা কি? কথা বলার সাথে সাথে তো রেসপন্স করবে, তাহলে বুঝবো কি করে যে তোমরা বুঝছো?
Discussion on
আমি
Smera.
আমি মাস্ট নিড
Yes,
কুইক
sir.
রেসপন্স।
Okay, sir.
So, this part already complete. Just now some discussion. Okay. So this the whole are described. Okay, this is the bus interface unit, and this is the execution unit. Bus interface unit, this is the whole are pointed, and this is the whole discussion. This is the segment discussion. Okay, clear? And now your another question, just only register structure. Draw the register structure. Draw the register structure and discussion the register structure. Only register. Okay, this is your second question. Only register structure. These are only register structure. Okay, this only register structure. Bus interface, you know that bus interface general purpose register AX, BX, CX, DX, and SP, BP. This is the stack pointer, base pointer, and this is the destination index and source index, and this is the flag register. These all are execution part register, and this is the bus interface unit part register. This is the IP ports and IP and all segment register. Okay, this is the internal communication register or temporary register. This is not the valuable register. Okay, this is the valuable register. This, so only your, suppose your question, draw the register structure, so draw this circuit, this diagram, and discussion this part. Okay, clear?
In exam.
Yes, in exam. Your second question, suppose one question, your another question, architecture of 8086 microprocessor, and draw the architecture of 8086 microprocessor. So whole part draw. Okay, and
Also the description.
also the description depend on, suppose your depend on your question. Suppose description only execution part, so only execution part description. Suppose description only bus interface part, only bus interface part description. And your second question, suppose your another question, in another question, this is the register structure of 8086 microprocessor. This is the register structure. Clear? Register structure, only register. And discussion, this only register part. This is your second question. And your third question in this architecture, third question, only flag register, draw the flag register. You know that flag register, already discussed your flag register, right? Previous class.
Yes. Sir.
Audits JAPC. Clear?
Yes.
You know that audits JAPC.
Yes, sir.
Audits, ODITS, audits JAPC. Audits JAPC. This is the short format.
Yeah.
This is the overflow flag. Overflow flag. This is the overflow. Then this is the direction flag. Direction flag, and this is the overflow flag. This is the carry flag. Carry flag. Suppose your result is carry. Okay. Your summation. Suppose you just in carry. This is the carry flag is high. Carry flag is 1. Okay. Carry flag 1 means carry is active. This is the parity, or parity, or even parity. This is the auxiliary carry. Auxiliary carry means after 4 bit 1 carry. This is called auxiliary. 4 bit. 4 bit means nibble. Okay. Suppose your summation total 8 bits. Okay. Suppose this is the summation. So this is the 1 1. Sorry, 1 0. This is the 1. No carry. This is the 1 1. This is the 0. Then carry. So carry flag is high. Okay. And this is the 1. This is 1 0 1. So this is the 1. No carry. So carry flag is low. Now, this is the 1 1. This is the 0. This is the carry flag high, and this is the 4 bit. After 4 bit 1 carry. Okay. This is the 4 bit. Okay. So after 4 bit 1 carry, this carry name is auxiliary carry. Okay. So auxiliary carry is high. Yeah. Then this is the 1. Then now no carry. So carry flag is 0. Then 1 1. Sorry, now 1 0 1 1 0 1 1 1 0. And this is the carry, final carry. Okay, so this is your summation. Clear? So this carry flag and auxiliary carry flag is high, low, indicate. Okay, and this is the 0 flag. 0 flag means your whole result is 0. Sign flag, if your result is negative, then sign flag is high. If result is positive, sign flag is 0. Clear?
Yes, sir.
This is the trace flag. Okay, trap flag. This is the processing part. Okay, processing signal step execution mode. Okay, internal interrupt after the execution of the is instruction. Okay, this is called trap flag. And this is the interrupt flag. If interrupt in any interrupt, then interrupt flag is high. Direction. incoming or outgoing. Okay, this flag is active, incoming and outgoing. Overflow, this is the overflow. Our bit is 8, but this is not 8 bit, this is the 9 bit. Okay, carry, but this is the 9 bit. This bit is 9. Okay, our section is 8, all are 8, but this is the 9. So this is the overflow. Clear?
Yes.
Okay. Clear? So this
Yes.
all our description is flag register. Clear?
Okay, sir.
Okay. So this is the register structure. Okay, this is the register structure. Hold. Okay, this is the flag register. So discuss the flag register, and this is the small summary. General purpose register, you know that general purpose register should 16 bit. This is the AX, BX, CX, and DX, and 8 bit. This is the AL, AX, BL, BH, CL, CX, DL, DH. Okay, this is the 16 bit pointer register 2 pointer register, stack pointer and base pointer. Index register is 2, source index and destination index. Instruction pointer is 1. All are 16 bit. Okay, all register is 16 bit. This is the segment register is 4, and this is the flag register, 16 bit flag register, but active flag register is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay,
Flag
active in 9.
register, how does it work?
Flag register 16 bit, but active in 9. Okay,
How does it work, sir?
sorry,
How does it work? Flag register.
not clear your voice. How?
Okay, now it's okay.
Yes.
How does it work? How does it work, sir?
How does
It work?
1?
Not, sir. How does it work, sir?
Oh, how does it
What is the main
work?
function? Yes.
Okay, okay. Flag register, you know that flag register work, what the purpose? If your carry flag is high, then flag register carry is high. Segment register, this is our all data in needed the segment. Segment means different dividation. Okay. Code part is all code part is preserve the code segment part. Data part is preserve the data segment. Stack segment, all are stack part is stack segment, and all extra, all are extra values preserve the extra segment. So this is the segment register. Okay, and source index, all incoming index and outgoing index. This is the source and destination index. This is the pointer register, stack pointer and base pointer register. Okay, so already all parties discussion. Okay. And this is the special function, summarize all parties summarize. Okay. So this is the architecture complete. Okay. Yeah.
Yes, sir.
Yes, sir.
So now our today another topics, addressing mode and instruction set. Okay, addressing mode and instruction set. Our total 806 microprocessor, total instruction, how many instruction? You know that?
Sir.
806 microprocessor, how many instruction? Suppose this is the one instruction, move, M-O-V, move, this is the one instruction, move X, comma, BX. This is the one instruction. You know that this instruction, how the work, this instruction, BX register to data transfer AX register. This command means, Amir,
Yes, sir.
this command means BX register to data transfer AX register. Clear?
Yes, sir. Yes,
This
sir.
is the one instruction. And suppose this sum AX, comma BX. What do you mean this instruction?
The summation of X and BX.
X and BX summation and final result transfer to X register. Not only summation and transfer final result. Okay. Suppose this is the one summation coding. Okay, this coding name is assembly language. This coding name is assembly language. You know that assembly language?
No, so what does it mean?
You know, maybe you know that programming language C, right? C is the
Yes, sir.
high level language. Okay, this is not assembly language. This is the mid level language. Okay, assembly language is the mid level language, and low level language. Low level language, one kind of low level language, and machine language. This the only 0-1. Machine not understand move, not understand sum. Okay, machine only understand the 0 and 1. Clear? Our computer not understand move, right?
Sorry, sir.
Our
Don't
computer,
understand.
this instruction our computer not understand. Our computer understand this instruction to convert binary code. Okay.
Yes, 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 yes. Absolutely.
0,
yes.
0, 1, 0, 1. Okay, this
Yes.
is the machine language.
This is the
Okay.
method that
0, 1,
computer understands.
0, 1, 1, 0. This is the machine language. 0 and 1 binary code, and this is the low level language.
What is this?
Okay, assembly
Now?
language. Assembly language is the low level language. Assembly language, I will
Right,
discuss
Richa.
this. This is the language. Assembly language code. This is the code. Okay, this is the assembly language code. And this is not code. This is the all line is help line. Okay, you know that our programming C / and this is the not coding. This is the
comment.
comments. So these the comments. Okay. These assembly language comments mean rules. These the semicolon, using the semicolon. And programming C comments rules. These the / Okay, clear?
Okay, sir.
So now this is the program. Sorry.
Instruction.
You know that program?
Yes, sir.
What do you mean by program? Already discussed your Abdul Basir.
Yes, sir.
Program, programming language, instruction, opcode, operand.
Yes, sir. You have taken the fourth semester.
Yes. So program, a set of instruction. A set of
Instruction.
instruction. Suppose you are decide the one program. All friends are meeting in today evening. You set the program. So must be we need the some instruction. At first Amir, all friends are messaging. Okay, this is the one instruction. Second part, another 2 or 3 friends are calling in your rural distance area friends, just phone call. This is the another instruction. And another, suppose your another friend Abdaziz, he set the program menu, dinner menu. Okay, and another your full entertainment part. Okay, so all instruction complete, then one program is complete. Clear?
Yes, sir.
So these are a set of instruction, right? A set of instructions written to solve a problem. Written to one problem solve. All part, if one or two part is missing, suppose missing your phone call. So some student not coming this section, so your program not fulfilled. Clear? All parties complete. Your dinner complete, your entertainment part complete, your hotel preserve complete, all part complete, but not messaging your all friends. So your program is vanished, right?
Yes, sir.
Yes, sir.
Clear? So all program, all parties very, very important. All instruction is very, very important. Okay. So this a set of instruction written to solve a problem. Okay. All instruction is set. First instruction, Amir work this. Second instruction, if this work this. Third instruction, Aziz work this. All part, all the instruction. All instruction is complete. Then program is complete. Okay. This is the one instruction. These all are instruction. Okay. Clear?
Okay.
So
Clear, sir.
instruction and program complete. This is the instruction. This is the one kind of instruction. This instruction means this 205A, this is the hexadecimal data. This is the 16-bit data, because hexadecimal means one hexadecimal means 4-bit binary, right? So these are 16 hexadecimal data. These data transferred to AX register. Okay, so this is the one instruction. Clear? This another instruction. This data transferred to BX register.
Sir, can you repeat again the program that you have used? In this
Program.
Yeah, yes, in this data.
Yeah.
Which program? Which software?
This all are program. And this,
Yeah, I know
this
the
program name is assembly language program.
Yes.
Assembly language. I will discuss. Okay, wait. So this is the instruction. This is the another, all are instruction. So instruction means directions which a microprocessor follows to execute a task or part of a task. One task execution. This is the one task. One task, this data transfer to X register. This is the one task, one instruction. Clear? Another task, this data transfer to BX register. Another task, CL register is 0. And another task, AX and BX register is addition. And move sum X.
Sir,
Okay.
what does move it mean, sir?
Move, MOV, this is the not full name. Move means movement, transfer.
Oh,
Yes.
transfer. Means transmitting a data.
Transmit. Move means moving. Okay, transfer. Okay, this data, this 205A, this data transfer to AX register. This called move, MOV, move. Some this not full name. This called, I'll discuss. This is the computer language. You know that computer language. Computer language is two part. This is the low level language and high level language. Low level language is two part. One is the machine language and another is the assembly language. Machine language, you know that machine language 0101 binary. This is the binary bits. And assembly language, this name is English alphabets. This is the move, MOV. This is the English alphabet. ADD,
Yes.
add. Add means addition. ADD, add.
SUB.
Okay.
Sub. Yes.
Clear? This called the mnemonics. MNE, but spelling is mnemonics. M is omit. Okay, mnemonics. Mnemonics means short form of word, English word. Okay, mnemonics. Clear? Mnemonics means short form of English word. This, you know that our English word MOV, move, but this is the short form MOV, move. Clear? This is the ADD, add, but this is the short form, but you know that our full format is addition. Subtraction, SUB, sub is mnemonics, but full name is subtraction. Okay, INC, this is the increment. Clear? This is the short form is INC. Short form name is mnemonics. Assembly language short form is name is mnemonics. Clear?
Okay.
All are clear?
Yes, sir.
And you know that our programming C language is the compiler. What's the word compiler?
Sorry, sir.
Compiler, you know that compiler in programming C?
Yes, sir. Yes.
What's the word compiler?
No, sir. I don't know.
Compiler?
Sir, and
Describe the
it converts
compiler.
sir, high level to machine, sir.
Yes, convert your high level language. Suppose your programming language C. So programming language C coding to convert
Machine language like binary.
machine language, binary language.
Yes.
The compiler is the compile. This is the coding compile, error checking, and finally transfer to machine language. This is called compiler. This is the programming C using the compiler, but our programming assembly language compiler name is assembler. Programming language compiler name is assembler. Okay, this is the assembler. Clear? Assembler what? Mnemonics to machine language. Okay,
Sir, mnemonics means, sir?
short form of English word, mnemonics.
Okay.
Okay,
Okay, sir.
this is the move, add, jump, increment, addition, subtraction. Okay, all parties, the mule form is word, but short form is using our programming language, assembly language. Okay, this is the instruction. Okay, clear? HLT means halt, hold. Okay, clear?
Yes, sir.
So you know that assembly language is English alphabets. English alphabets using the English alphabet and using the mnemonics, short form of English word. And now finish the program. This the program is we need the as machine language, convert the machine language using the assembler. Using the assembler convert to mnemonics to machine language. Clear?
This is a numerics, right, sir, right? In this
Yes.
program, it's numerics.
Yes,
So
assembly language structure.
you're transferring to machine language.
Yes. Assembler is transferred the machine language. Okay. Also, our programming C compiler is the transfer is the machine language. Okay. Programming C, C++ using the compiler, but assembly language using the assembler. Okay. So now our whole instruction. This is the one kind of instruction already discussed. The move AX, BX. This is the one instruction. Okay. move X, suppose 3019. This means this data transfer to X register. Okay. Our register structure, you know that our register structure is the X register, right? So this 3019 is the 3019 transferred to X register. This common means clear. So this is the one instruction. And how many instructions in 8086? 8086, how many instructions? total instruction is 117. Total instruction 117. Clear?
How do I know, sir?
Sorry.
How do we know that this is 117 instructions?
Yes.
It is the maximum instructions.
I will discuss your next topics. Okay. So our
Okay,
total
sir.
instruction, suppose move, this is the one instruction, sum, this is the another instruction, this suppose, this is the INC increment, Okay, this is another instruction. So how many instruction? Total instruction is 117 numbers. Clear? How many? How many instruction?
117, sir.
117. Clear? But this the move means movement. This data transfer to X register. This command is another command, MVI. This also movement, but this is the move immediately move. Clear? This means move immediately move. But this the quickly move. So these the both are movement command, movement instruction. Okay, so move is one type of instruction, but these are different. This is the move immediate and this is the move. And suppose ADD, add means addition, means summation. Okay, so add and ADC, add AX, BX. Means X and BX addition, and finally final result transferred to X register. This means, okay. And another command, ADC. This is the same, but this not almost same. This is the ADC. ADD means addition, but this is the ADC means add with carry. This means add with carry, but both are addition. Clear? So both
Yes,
are one type, same instruction type. Instruction type same, but to know that our instruction is two part. This is the full instruction. Move X, this data. This is the two part. Instruction is two part. This name is opcode. This left side name is mnemonics part. Mnemonics part name is opcode. OP, opcode. COD, opcode. Okay, this name is opcode and this name is operand. Opcode and operand. Clear? Operand means operation. This is the operation part and this is the coding part. Move operation, this data transfer to this. So this is the operation part, okay? And this is the coding part. And since this coding part, this is the add, this is the opcode, and this is the operand X, BX, means BX and X data addition. So this is the operation. Clear?
Yes, sir. Yes.
So opcode and operand, our instruction is two part. Instruction is two part. Opcode and operand. So opcode is different opcode. This is the MVI is one opcode, MOV is another opcode. But instruction same. Both are movement instruction. Clear? Like as ADD, add, and ADC of instruction almost same. Both are addition. But work is different. This is the opcode is different. This is the add and this is the add with carry. And suppose SUB, subtraction. SUB means subtraction. And SBB means subtraction with borrow. Okay. So instruction same, but opcode is different. So total our 8086 instruction 117, but opcode is 300. Opcode is 300. Clear?
Yes, sir.
Instruction
Are they in same position, sir? 8086 and opcode.
8086 opcode is 300.
Yeah, I know that India instruction is 300 for opcode. So are they in same position? Can we compare it? 8086 and opcode.
8086 only 8086 opcode is 300 and instruction is 117. Suppose 8085 instruction is 78 instruction. Okay, different microprocessor, different instruction. Now our instruction is huge. Our present microprocessor Pentium Core i7 বা Core i9, this is the huge instruction. But our previous 8086 microprocessor, this instruction is only 117 type of instruction. Summation, addition, summation, subtraction, division, multiplication, increment, decrement, okay, jump, different instruction. I'll discuss your next class. Okay, so total instruction are addressing type is called addressing mode. Total instruction are some type of addressing mode are different definition. Different. This addressing mode is total 12 addressing mode, but not 12. Total 5 addressing mode. These addressing mode are 2 part. Another this the 6 part. These the 2 part and this single. Okay. So total. These the addressing mode are 5 category. Addressing mode are 5 category. Means our total instruction and opcode are addressing is 5 category. Clear? And this I will discuss your next class addressing mode and instruction set. Our total instruction 117 and opcode 300. This total instruction is just different section is setting. This called instruction set. Okay.
Set of instruction.
A set of instruction. Okay. Some instruction is one name instruction type and another. Suppose our all mathematical instruction called all arithmetic instruction and another all logical part, logical instruction. Suppose XOR and or this instruction, all instruction is logical instruction. This is the another part.
Yes, logical operations.
Logical instruction. Arithmetic instruction, our addition, subtraction, multiplication, division. Okay, this part is mathematical instruction or arithmetic instruction. Okay, so different set category is different instruction. Okay, so our previous next day our class 2 part addressing mode and instruction set. Okay, this addressing mode is 5 category. Suppose I will discuss today is just first part. This is the addressing mode for register and immediate data. This is the one category name, register and immediate data. Clear? These are 2 parts. And first register addressing mode and immediate addressing. Just example, register addressing mode means register transfer. Okay, this is the addressing mode for register and immediate data. This is the register to register communication called register addressing mode. Suppose move move x comma bx. This transfer, this is the AX register to BX register data transfer. Register to register transfer. You not understand how what's the data in is of this register. hide this data. Just this is the AX register and this is the BX register. So BX register data, this data transferred to AX register. Okay, so this called register at the signal. Clear? Register to register transfer. Suppose move CX comma DX. This also registered at the signal. Register to register. Clear?
Yes, sir.
And sum, sorry, or add, addition, and X comma BX. This also register to register at the signal. Okay, register to register transfer and register to register addition. All are using the register. This is called register at the signal. But immediate at the signal, one is the register and another is the data. Suppose this command move X comma, this is the data 3019. This is the hexadecimal data, 16-bit data. This data transferred to AX register. So this is the one data and one the register. This is the example of immediate at the signal. Okay. And suppose add X comma 3019. This means 3019 and AX register. Suppose AX register data 1520. So 1520 and 3019, these both are addition. Clear? So this is the visible and this not visible. This is the registered data. And this is the input data. Okay. Clear? So this called immediate at the signal. Both are example is immediate at the signal. Clear?
Yes, sir.
And this called register at the signal. Register to register transfer. Okay, these all are register to register transfer. This already discussed this. This is the register at the signal. Move CL comma DH. This is the 8-bit and 8-bit. This is the CL, this is the CL, and this is the DH. So this 8-bit to transfer DH to transfer CL. So this is the 8-bit register to 8-bit register transfer. So this is the register at the signal example. Okay, clear?
Yes, sir. Clear.
And
Yes, sir.
and this is the immediate at the signal. This is the 808. This is the 8-bit data. Okay, this 8-bit data to transfer DL register. This DL register. This DL register transfer 08. This is the one data and another register. Okay, 8-bit data given to instruction to move the DL. Okay, so this 08 data transfer to DL. This is called immediate addressing. Okay, and this is the 16-bit data. 16-bit data using the AX. So AX register data transfer to this. This data transfer to AX register. This is the 16-bit and this is the 8-bit. So this is the immediate addressing bit example. Clear?
Sir, how can I recognize their bits?
Sorry?
How can I recognize whether they are 8-bit or 16-bit, whatever? How can I
Yes,
recognize?
no problem. Just your data, depend on your data. Our depend on your program. Suppose your program in 8-bit data, so no need the 16-bit
No,
to
sir.
transfer.
Sir,
You need
how
to
can-
transfer. Wait, you need to transfer 59. This data transfer to register. So you know that this data is 8-bit data.
But
This
how do I know it's 8-bit? How do I know? It's
is the
8-bit or
hexadecimal.
16?
Hexadecimal means one data is 4-bit binary.
Yes, sir.
And these the two hexadecimal data means 8-bit data. Already discussed in previous class.
16-bit, yes.
So this is the 8-bit data. So 8-bit data must be needed 8-bit register, not 16-bit register. And this data is 0A9F. This H means this hexadecimal data.
Because
So hexadecimal 1 bit means binary 4 bit. So 4444. This is the 16 bit.
This is
So
16
must be
years.
needed the 16 bit register, not need 8 bit. So 16 bit register, you know that AX, BX, CX or DX, any. You using any AX or BX or CX or DX, no problem.
now
Okay,
we use it X.
clear? So just today I'll discuss register address mode and immediate address. Clear?
Yes, sir.
Yes. So your next day I will complete these two name is immediate address mode for immediate and register data. Address mode for register and immediate data. Okay.
We go. So how many can you bash and so upload grade in news? Then what are the new?
So the girl to video that
So dig new la ku adkaysa xaw new ardada way caawinooyin u sheeg saxaw ana dalaad markas waa la waxaan iskama bedelinayo ardadan hadla dhisaxaw
I cool.
ha new maalintii hal cashir oo soo dhigay ilaad mu soo dhiganayo ardada hadla
هذا حيسة الجرم بالعادة.
may taasa kulin waxa waay oo soo galay anoo wuxuu dhaniyo macnaha review sameeyo dhahay xooga ardadan xayr ka taataaba dhahay waa soo laabanaa marka imaad loo bilaabay
وايا بنيو سيستم كورا كل نادي إلى بنا
marka ardadan niyo ninkan ku goobta dheesaxaw si kale wax ma ku soo dhigayniyo
دارا وشيء سوكا
أنا اللغة مع القصة شوي ما يهدر لحظة اللغة نيو
ترفع الصورة ترفع الصورة أصلا
Okay, so clear?
yes sir
Okay.
Sir.
So today our class is finished. Okay.
okay sir
Yes.
we are requesting that you
Upload.
have to upload yes video
Okay. Okay.
all the videos okay sir this
Okay,
video and the previous videos
Okay. Today night I will submit all video. Okay. Amit,
okay thank you so much
you just send your all student roll number. Okay. In this group. Okay.
okay I will text screenshot wait sir قفل في جات بوكس كسو قريا جات بوكس كسكرينشوت
Total 14%. Okay. So thank you very much.
okay thank you so much